7th graders, it's Mrs. Tremblay with lesson 8.0, Measures of Central Tendency. You're not going to find this lesson in your book. This was actually something you covered last year, but we need it for the stuff that you're going to learn about this year, so I thought it'd be nice to review it. So what's a measure of central tendency? It's a measure that represents the middle of the data set. Mean, median, and mode are the measures of central tendency. So just remember, central tendency, MMM. Anyway, the mean of the data set, that's just the average of the data. And all you have to do to calculate it is add up all the numbers in the data set, and then you divide by the number of numbers that you added, or the number of values in your data set. So for example, let's say that first quarter, your test scores in math were 100, a 98, a 94, a 94, and an 89. And I ask you, what is the mean of your scores? I'm just asking you for the average. So I think they call it mean because it takes the longest to calculate this one. Like, oh, it's so mean, it takes forever. That could be why. Us mathematicians are crazy when we name things like that. I had no part in it. Anyway, all you're going to do is you're going to add up all of your scores. So I gave you 5 test scores. And 100 plus 98 plus 94 plus 94 plus 89. You'll do all that, and when you add all those up, you get 475. That's not your average test score. Wouldn't that seem kind of crazy? You can't even get past 100 on a test. You can't have an average of 475. Oh, we forgot to divide. Yeah, once you add them all up, then we're going to divide by the number of numbers in the data set. So there were 1, 2, 3, 4, 5 numbers in the data set. You take 475, you divide it by 5, and our average test score then would be a 95. Okay, so that's the mean. Add them all up, hit enter, divide by the number of numbers you added. There is your mean. Wonderful. All right, the median, it's another measure of central tendency. And what is the median? It's the middle number when the numbers are in numerical order. When there's an even number of values in the data set, the median is actually the average of the 2 middle numbers. So I showed you one of each. So in both of these, I ask you, find the median of each data set. What you should do first, whenever you're looking for a median, you should make sure that the data values are in order. And in looking at this first data set, they're not. So let's put them in order. I'm going to look for the lowest. Always going to go from low to high. So it's 50, 40, 90. Oh, 36 should be first. And then we have 42 and 57, 86, and 90. So that's step 1. Put them in order. Now, I want to figure out what the middle number is. So usually what I do is I use the 2 thumbs method. Thumbs up. Woo! I'm going to cover up the first and the last and just work my way in, first and last. And I see, oh, 57 is right in the middle. If you want to make sure you chose the correct number in the middle, then count and make sure you have the same number of numbers on either side of it. So there's 2 numbers to the left and 2 numbers to the right. Yay, we're right. So 57 will be the median of this data set. All right, the next one here. All right, we have 36, 42, 55, 57, 86, 90. Oh, sweet. Those are already in order. We don't have to do anything. That's nice when that happens. Although there is something else that's going to take place. So get your thumbs, your 2 thumb method. 36 and 90, 42, 86, and then, if I move in, then I'm left with nothing. So what we have here are 2 numbers in the middle. You can't have 2 middles. So what you need to do is find the middle of the middle. I know, it sounds like fun, doesn't it? Maybe. All right, so 55 and 57. Some of you might be looking at this thinking, it's 56, Mrs. Tremblay. It goes 55, 56, 57. 56 is in the middle of those 2. Well, yeah, some of them are obvious like this, but when you don't have an obvious middle, what you're going to do is you're going to find the mean of these 2 numbers, or the average of these 2 numbers. And remember, to find the average or find the mean, you add up the values that you want to find the mean of, and then you divide that by how many numbers you added. If you're using a calculator, make sure that after you type in 55 plus 57 and hit enter, after you do that, please make sure that you hit enter. Because if you don't, your calculator is going to divide by 57 by 2 and then add 55 to it. You're going to get a really big number for your middle, and it won't be right. So 55 plus 57, enter, divide it by 2, and we already said we know it's 56. So that's how you do it when the numbers aren't quite as obvious, especially if you had some decimals in there, or you had some fractions, or you had numbers that were really, really super far apart. That's how you do it. So there's median. All right, the other measure of central tendency is called the mode. And the mode is just the number that appears the most in a data set. I think mode kind of sounds like most if you're trying to say it with a cold. Like, I had the mode fun last night. Maybe not. Whatever you need to do to remember that mode means most, do your own thing, because I think mine is probably pretty silly to you. We'll see. All right, so the mode, it's the data set that appears the most. There can be more than one mode in a data set if the number appears the same number of times. It's not just a number that appears more than once. So in looking at this, here's a data set. We want to find the mode, so I want to find the number that appears the most. 10 happens once. I see that 15 happens 3 times. 16, 17, 18 happens twice. And 20 happens 4 times. So the number that appears the most is going to be 20. Because 20 happens 4 times, 18 happens twice, and 15 happens 3 times. So it's not about appearing more than once, it's about appearing the most. So 20 would be your mode. All right, so those are the measures of central tendency. We're going to talk about 2 other things, and I'm sure that you have learned about these before, but it's always nice to have a little refresher, especially when you're going to be expected to use this stuff in this unit. So you also have to know how to calculate the range of a data set. And that just describes how spread out the data are. And all you have to do to calculate the range is take the high minus the low. And that's basically what all this stuff says here. So going back to your test scores, you have 100, a 98, a 94, a 94, and an 89. And I kind of want to know, well, how spread out are these? From your lowest score to your highest score, how many values are in between there? What's your range of data? So all you're going to do is find the highest score and the lowest score and subtract them. Make sure you take the highest minus the lowest. Otherwise, you're going to get a negative number, and that's not going to fly. So when you take 100 and you subtract 89 from it, yep, you get 11. So your range of values is 11. All right, another term that I am sure you have heard before, it's one of my favorites. It's called an outlier. Basically, an outlier is a value that is much smaller, or it could be much larger than all the other values in the data set. So picture this. Your test scores, let's say you got 100, a 98, a 94, a 94, and a 2, right? A 2 would be way smaller than all the rest. That would be considered an outlier. So this was a 2 instead. What's going to happen is when you find the average test score, it's going to end up being way lower than what your data says it should be. So what outliers do is they kind of mess up your mean. So if you see that a data set contains an outlier, it's better to use the median for the average of the data set, because outliers can make your mean appear higher or lower than what it actually is. All right, and I know that you talked about that last year, so I'm done. I won't talk about it anymore. Maybe in class, just a smidgen, but I'll be done now. But I want you to make sure that you're able to identify outliers in a data set. So if I ask you, what's the average of the data, you can choose the median or the mean. So one last time, if there isn't an outlier in the data set, the mean is going to be the best way to find the center of the data, the average of the data. If there is an outlier in your data set, then the median is going to give you a better picture of what the center of the data is like. All right, so in looking at this data set here, I give you 3 of them. It's not a multiple choice question. It's 3 different problems that we're going to do. I ask you to identify the outliers in each data set, if any. So that means that there might not be an outlier. Outliers are a lot easier to identify if your numbers are in order. So just like when we were finding the median, we put the data set in order, we're going to put this data set in order as well when we're looking for outliers. So this first one I can see, it's not in numerical order. So I'm going to find the lowest, which is 17. And the next one looks like 63. And we have 67. And I'm sure I've mentioned this in class, but just in case, yes, you write down everything I write down. I know it's difficult, but you can do it. All right, so now we have our numbers in order. Outliers are either going to be at the very beginning or at the very end of a data set. And basically just look for a number that's way smaller if it's at the beginning or way larger if it's at the end. In looking at the beginning of this data set, it jumps from 17 all the way to 63. And then I have some 60s and some 70s and some 80s and some 90s. So if you can kind of notice, the 60s, 70s, 80s, 90s, those kind of flow. There's a big gap between 17 and 63. So in this case, I would call 17 the outlier. 17 is a lot smaller than all of the rest of the values in that data set. If these were test scores here, it would make it look like your average test score was a lot lower than it should be if we calculated the average of it using that. If we took out the 17, that would give us a better picture of what your average score was. So in this case, I would want to use the median as the average of the data set instead of using the mean. All right, look at letter B. First off, are these numbers in order? No, they're not. So let's put them in order. I have 104, that's first, 111, 115, 126, and 412. And I always do cross those off as I go. I think it's a nice visual way to not use the same number twice. I don't know about you, but I make those silly little mistakes a lot because I do everything really fast. You'll find out. Okay, so in looking at this, I have 104 to 111, 115 to 126, and then 412. The beginning data here, this kind of flows. There's not big gaps in between, but jumping from 126 to 412 when all these other values were in the low 100s, that's a big jump. So 412 in this case would be my outlier because it's way larger than all the rest. So if I added all these together and found the mean of it, it's going to make it look like the average of my data is a lot higher than it really is. In this case, it would be better to use the median to describe the central tendency of the data, to describe the center of it. So I would use a median here, I would use a median here. Let's look at this last one. Okay, when you're identifying outliers, we want to make sure the data's in order. 2, 7, 10. Oh, look at that. I gave you one that's all in order. Woo! Okay, so we don't have to do that. Now I want to look for any numbers that are way smaller or way larger that kind of stand out. Well, I see a 2 here and I see a 40 here. So right off the bat, I might think, well, this 2 must be an outlier. And as you're looking at this, I go from 2 to 7 and 7 to 10. So I jumped 5, I jumped 3, I jumped 5, I jumped 10, jumped 5, jumped 6, jumped 4. I wouldn't consider 2 an outlier. I don't think 2 is way smaller than all of the rest of the values in this. And 40 isn't way larger than 36, is it? So with this one, I might have a pretty big range. 40 minus 2 is 38. However, there isn't an outlier in this data set because all of the data values kind of flow together. There isn't one that's way smaller or way larger. So there are no outliers. I don't have to take any numbers out of the data set. And if I wanted to find the measure of central tendency for this, I would use the mean. I would find the average of it instead of the median. But generally the mean and the median are pretty close, unless there are outliers. Right, you are done. I'll see you tomorrow.